Hi everyone, this is Stuart from the Planning Analytics team at IBM. Today I'm going to demo some enhancements to the GIT capabilities that are exposed in the Modeling Workbench in Planning Analytics Workspace 2.091. This demo I'm going to perform on the Planning Analytics SaaS on AWS environment. So to start the demo, I'm actually going to create a new database. I'm going to call this database Planning Sample New. We'll assign 40 gigs of disk space to this database and 4 gigs of memory, which should be sufficient for the objects within the planning sample demo database. If this screen is not familiar to you, it is because it's the self-service user interface for creating and scaling databases in the new Planning Analytics SaaS on AWS offering. So I'm going to go ahead and create this database. It should be created within about 30 seconds or so. Now, the objective of this demo is to actually show how we can take objects from our planning sample database, just one of our sample databases that we provide, and push them to a Git repository, and then pull those objects from the Git repository to this planning sample new database. Once this planning sample new database is created, once it's finalized, we'll take a look at it in the modeling workbench, and we should see that there are no objects within the database. We'll just give it a couple seconds here to finish creating. Now, if you've seen this demo before, it may be a bit familiar, right? Because we've demoed this sort of capability where we push objects such as cubes and dimensions and processes to a Git repository and then pull them into another database in the past. This is going to be a little bit different because it's also going to allow us to bring some cube data from the database to the Git repository, and also things like attributes and attribute values to the Git repository and then back down to the database. Okay, so our database is completed, planning sample new. So if we switch over to the modeling workbench, we should see the database here. And of course, because we just created this database, it's empty. It's got no cubes, there's no dimensions, no processes, just the few control objects that we'd expect to see in any TM1 database that's been created. On the other hand, this planning sample database, it has cubes. If we drill into this, we can see the cubes have views. If we open up these views, we can see that they have data. If we examine the dimensions, we can see that these dimensions have attributes, right? And of course, it has attribute values as well. So we want some of this data and some of these attributes and attribute values to make their way into the Git repository and then back down to this other database, which is currently empty. So we'll go ahead and we'll start the Git operation by right-clicking on the planning sample database. We'll go to remote repository operations, and we'll say add objects to repository. This information is pre-configured just because I previously used this functionality within the same session. But I do have basically this public key and private key sitting in Notepad to copy paste in here, as I do this demo. But keep in mind, we do sort of store this information just within the same session. So if we were to log out of Workspace and log back in, the public key, private key, and passphrase would be empty. That's expected. We don't stash that information permanently, but we do store the URL for the Git repository. So we'll go ahead and we'll click next because our authentication information has already been pre-configured, and then we'll start selecting objects. So this screen is probably a bit familiar, but there's a few new things on the screen that didn't exist in 2.090 and lower. I'll go ahead, I'll pick the cubes, I'll pick the dimensions, I'll pick our turbo integrator processes, our chores, and here we see the first thing that's new, which is the ability to pick web sheets. In this case, I'm just going to simply select all the web sheets from the model. The other thing that's new here is the ability to pick files. So when I select files here, up at the top right, we have an option to add files. So we can add files to basically a list of files that we want to move from the model to the Git repository. In this case, I'm not going to pick a single file. I'm going to pick this Git directory. And if we take a look at this Git directory, it has some subdirectories right now. I'm going to clear these subdirectories out. These have some files sitting in them from the previous kind of execution of this demo. But I'm going to clear these out basically so this Git directory is empty. Of course, it doesn't really matter if it's empty at this point. We'll explain the purpose of this particular folder. But keep in mind, what we really want to do here for the purposes of this demo is simply pick this folder. Right? When we pick this folder, what we're really stating is that we want this folder and any of the contents in the folder to be pushed to the Git repository when the push operation actually completes. I'll stop and make a quick note here. This functionality to see folders within the file manager is unique to Planning Analytics Engine. It doesn't exist in the Planning Analytics offerings that use TM1 version 11 today. Our intent is, of course, to extend the file manager capability with offerings using TM1 version 11. So we can create folders to kind of organize files in here and have a place for things like turbo integrator processes to output files to. Of course, that does not exist today with Planning Analytics on Cloud or Planning Analytics Local. So in those offerings, there is no capability to kind of create and pick a empty folder here. It doesn't exist yet. It only exists in the Planning Analytics SaaS on AWS offering or offerings using the Planning Analytics Engine database. So we'll go ahead, we'll just confirm one more time that this Git folder is there and it's empty. We'll select the folder and we'll kind of move on to the next step here. So now that we've selected our objects, we'll click the next button. And this screen is also new. Again, it's completely optional as the UX tells us, but we're going to enable this. And then we're going to enable only our pre-push tasks and our post-pull tasks. Pre-push tasks are basically just the turbo integrator processes that we want to run before the push operation starts. And we have a purpose-built turbo integrator process, which I'm going to show and share as well, that is going to allow us to export things like cube data and attributes and attribute values to files. I'm only going to pick this Git export process, but keep in mind this Git export turbo integrator process will call this Git export attributes process and this Git exports data process multiple times, one for each dimension where we want the attributes, one for each cube where we are going to export the data from the cubes and push that data to the Git repository. So we'll go ahead and add this Git export process, which again is basically just an orchestration process. And then we'll basically do the same for the post-pull tasks as well. And of course, this one is called Git import. And we'll add it. And again, I'll share these turbo integrator processes along with the video. It's my own turbo integrator code, but of course you're welcome to take it and modify it to kind of suit your needs however you want to use pre-push and post-pull tasks. This Git export process, it does take two parameters. The parameters are actually the names of subsets, right? So I'm expecting subsets called Git. These subsets will end up existing in the dimensions, the curly brace dimensions dimension, and the curly brace cubes dimension. So we expect to have these two subsets. They're both named Git. The way the turbo integrator code works, though, is that if these subsets don't exist, it'll simply create these subsets, and it'll populate the subsets with all the dimensions in the dimensions dimension that are not control dimensions, and all the cubes in the cubes dimension, which are not control cubes, right? So it basically assumes that you would want the attributes for all the non-control dimensions and all the data for the non-control cubes to be pushed to the Git repository. And again, this subset that it creates, you could call it anything you want. I just called it Git because it's relevant to the test case here. So we'll save this. We'll just double check this one more time. That's correct. And then we'll actually run this. In this case, we'll create a new branch. Call it demo branch 1, and we'll base this on the existing main branch. We'll put a commit message called pushing everything. Of course, you can put whatever message you want in here. And here we also see a new piece of functionality because there was a lot of configuration steps in order to to kind of configure what is going to be pushed. I may want to save that configuration. So I can name a file here called save config, and this will basically create a file that's going to sit on the database as well that I can recall later, which will sort of load the configuration that was used to pick the objects and to configure the pre-push and post-pull tasks that I'm going to use. So I'll go ahead and I'll click add here, and we can see this is actually running. If we wanted sort of proof positive that it is running, of course, we could always go to Planning Analytics Administration. We could look at the Activity tab. Again, if you're still in the TM1 version 11 world on Planning Analytics Cloud or Local, this would be the old Threads tab where you could see this activity within the threads. In the modern SaaS world, we see this as activity, but we can basically see the activity running here, and it's actually executing the push plan at this point. So this should run, and after a couple of minutes, we should see it complete. We'll see the activity fall off, and we'll switch back to the modeling workbench. And at this point, nothing has changed in the model, in either the existing old model or the new model that we're trying to push content to. If we refresh this, of course, we still see no cubes. But what we're going to do is we're going to switch tabs in our browser, and we'll take a look at our Git repository. Right, and in here we can see a message that demo branch 1 had recent pushes less than a minute ago. That was our activity. So if we dig into this branch, You can see all the content that we'd expect to see, you know, the cubes folder, the dimensions folder, the chores folder. If you haven't seen this before, the real kind of beauty in this is that we can dig into these and we can look at things like our chart of accounts dimension, for example, and in plain text or human readable text, really it's JSON, but it's fairly human readable. We can see our list of members, you know, details about the members such as their type, and then we can also see things like the edges, which is the detail within our hierarchies that kind of explain the parent-child relationships between the various members. You know, the real beauty of this is that, you know, because of course it's in kind of human readable text, that as we make changes and push those changes to the Git repository, we can use Git to kind of track the changes and see what changed, right? In the case of a hierarchy, it would mean detecting which members were added or removed and which parent-child relationships were changed or have changed over time, right? So again, this is nothing new. This is capabilities that exist in 2.090 and lower to kind of push all these objects such as dimensions and cubes and processes. What is new is this files directory that's showing up. And if we dig into this, we can see two subdirectories. One is the directory that contains the web sheets. And here we can see the folder structure that we'd expect to see for our web sheets. And you know, if we dig into the externals directory, you know, we can actually see the Excel files for the web sheets themselves sitting here. The other thing that we see in this this files directory is our Git folder, which we told the Git capability to push to the repository. And if we dig in here, we can see some content that was generated. One is an attributes directory, which contains CSV files that have all the attributes. If we pop this open, one of these, we can see details such as the type of attribute, in this case, you know, an alias, things like the member ID, the attribute name, and then of course the attribute value. So all this information, we basically run a process which extracted this from the hierarchy or the dimension to a CSV file, and then we push that CSV file to the Git repository. Right, and of course, we can run a turbo integrator process to read this content and to use it to both create the attributes if they don't exist and populate attribute values for each of the members in this dimension. Right, so this has all been pushed to the Git repository along with our cube data. So if we can get back to this kind of Git folder here, you know, we can click on the cubes folder and we can see the data that's been exported for each one of these cubes. And this is fairly small amounts of data. I think most Git repositories have maybe a 50 megabyte limit. So, you know, if you have more than 50 megabytes worth of leaf data in your cube, you know, it's probably not going to be able to be pushed. But, you know, this is really probably intended for, you know, smaller cubes anyways, where those cubes contain important detail such as parameters that are kind of pulled into turbo integrator processes and other sort of control and orchestration information that, you know, that we find in most TM1 models. So, you know, and now at this point, you know, we have all this sort of objects and some data sitting in our Git repository. So we'll go back to our modeling workbench and we'll switch over to our, you know, our new database. And here's where we'll start the operation from remote repository operations to update this model, this currently mostly empty model, from the same Git repository. So here's where we need to fill in some information because this is a you know, a brand new database. This information has never been cached. We're going to put in the same kind of authentication information for the Git repository. Again, I'm just copy and pasting this from Notepad and typing in a passphrase. We'll click the authenticate button. And then we'll go ahead and pick a branch. Of course, we're going to pick demo branch 1, which is the branch we just created. We'll click the update button. We get the message here that it's creating an update plan. Within a couple seconds, we get some detail explaining what is actually going to be pulled into the model. So we're going to see that these cubes are going to be created, these dimensions are going to be created, these turbo integrator processes are going to be created. Importantly, the processes that are going to be created include these get import and get export processes. We're going to see one chore is going to be created. Some files are going to be created. Here we can see the files that represent our web sheets. Notice that they're actually paired. You know, there's a JSON file that's kind of paired with an XLSX file. And then here's all of our CSV files that contain both our attributes and our cube data. This other section here, this basically just tells us that a post-pull task is going to be executed. And of course, that post-pull task, it's going to execute our get import turbo integrator process. So we'll go ahead, we'll execute this. And while it's running, again, we can switch over to the Planning Analytics Administration. We can take a look at our planning sample new database, go to the activity tab, you know, and we can see the activity running here. right? And if we refresh this a couple seconds, every couple seconds, eventually we should see that it completes. And once it's completed, we'll go back and check our database, our new database, to see the content that was pulled into it. Okay, so it's done. We got our toast notification stating that it's complete. Let's close these because they're from the original planning sample database, and we'll start refreshing some objects here. So we'll refresh our list of cubes. We can see that all the cubes were pulled in, of course, with the things like the rules that we'd expect on the cube. But more importantly, right, if we examine these views, we can see that indeed data was pulled in. If we look at the dimensions, if we refresh our list of dimensions, and we look at one of the hierarchies in this dimension, plan chart of accounts hierarchy, again, we can see that this contains both the attributes and the attribute values that were pulled in through the GIT import process. So really quickly before we end, we'll go and take a quick look at those processes. And of course, like I said, they were pulled into this database as well. So if we look at the export process, again, nothing too complex in here. It's basically just some turbo integrator code which looks for the existence of a subset, where that subset by default it's named GIT. If it doesn't see the subset, it's going to create that subset and add members to that subset where the members are not control dimensions. Basically the members of the subset are the names of the dimensions that are not control dimensions by default. But if you wanted to carry over attributes for a control dimension, you could just manually build the subset called GIT yourself. And then we have some code here which is going to iterate over the members in that subset and run the GIT export attributes function for each member within that subset. There are some checks here just to make sure things like the dimension isn't completely empty. So there's a bit of kind of safety logic in here just to make sure nothing silly happens. But effectively, all this is doing is running the GIT export attributes turbo integrator process once for each dimension, each member that's in that GIT subset in the dimensions dimension. The code is basically repeated for cubes, again, building a subset with the list of cubes and executing this time the GIT export data turbo integrator function for each cube in that subset in the cubes dimension. If we examine the export attributes process, it itself is very simple. It's simply constructing a native view, a temporary native view in the element attributes, whatever your dimension is dimension, and then exporting that data to a file. One thing that I will note here, just because this is planning analytics engine on the AWS offering, is that when we run this, our ASCII output function here names a directory where the directory is called git/attributes, and it creates these files here. This ASCII output function, it works a little bit differently in Planning Analytics Engine than it does in TM1 version 11, where it'll actually create the directory for you. So if this /git/attributes directory doesn't exist, or just the /attributes directory inside of the Git directory doesn't exist, this will automatically create the directory as it creates the files within this directory. It's a bit of a subtle change in the way that Planning Analytics Engine works, just to support really the concept of running the database as a service and not having a separate file system that the database is dependent on. So if we examine the Git export data directory or turbo integrator process, we can see that same idea. It's simply creating a view in here. So it constructs basically just a native view. If you had alternate hierarchies in use, you might need to construct a MDX view where the MDX view contains things like the leaves hierarchies from dimensions that contain multiple hierarchies. But either way, this is doing something really simple. It's creating a view and it's using that view to export all the leaf data from the cube. So very simple, something that we all probably have within our turbo integrator processes within our models. The data section here, it looks like a lot of if statements. That's simply because it's kind of pre-configured to work with cubes of any size, up to, I think, cubes with 12 dimensions here. Right. So this just looks at how many cubes are how many dimensions are in the cube that it's exporting, and then the logic is conditional to kind of work with with however many dimensions are in the current cube. The import processes, it's basically the same thing in reverse, although the import process for orchestration here called git import, it's simply looking at the git attributes directory and the Git cubes directory. It works off of files within those directory, and then it simply executes a turbo integrator process for each file it finds within that directory. This is a bit of an example of how the wildcard file search turbo integrator function can be used in Planning Analytics SaaS on AWS to kind of iterate and process the contents of a directory. And then, of course, if we look at things like the import attributes, turbo integrator process, again, a very simple piece of code. It's simply creating attributes and adding attribute values for each row within the data source file. Same thing for this data one. It's importing cube data. Again, a bunch of conditional logic within the data section here, to support leaf level cells that are numeric or input. It checks that they're updatable, and then it's variable based on the number of dimensions in the cube that it's loading to. So really not complex code, probably code that, again, we all have within our turbo integrator processes within models somewhere. In a lot of ways, it's nothing new. But you put this all together, and of course, we get the sort of configuration where we can push objects to the Git repository and pull objects to the Git repository. And then things like attributes, attribute values, select data from cubes can also be pushed and pulled from the database to the repository. And as a way to kind of move more than just the objects themselves, right? You could extend this sort of concept to work with other things as well. Of course, security data within models is it's data that exists in cubes. We have like element security cubes and cell security cubes and the cube security cube. So if you wanted to pull over that security data, again, you could probably create another set of kind of turbo integrator processes to import and export the actual security data on cubes that you select as well. So there's a lot of flexibility in terms of being able to kind of write your own turbo integrator code to export and import whatever data or metadata you want from objects in the model to files. And then we simply move those files to and from the Git repository in order to actually move that data around with the objects. Okay, so with that, that's been a bit of a demo of the upcoming capabilities in Planning Analytics Workspace 2.091. Again, at the time of this recording, the current release is 2.090. So this should show up in or around the end of October, early November within the product. Definitely, it's accessible both in the modernized offerings with Planning Analytics Engine and the classic offerings with TM1 version 11. Again, keep in mind that if you are using offerings based on TM1 version 11, this file manager capability in here is a bit limited in that it will only carry over content or files that are sitting in the directory that is sitting underneath that file manager, which is a directory called model_upload inside of your data directory. That directory in TM1 version 11, it's actually managed by the Planning Analytics Administration agent. But again, it is our intent to enhance that simply so we can create things like directories in that model upload folder. You could export content from data from your cubes or metadata to those directories, and then select those directories to move them to the Git repository as well. So what you see in this demo, it would definitely work today if you're in Planning Analytics SaaS on AWS. If you're on Planning Analytics Cloud or Planning Analytics Local, it definitely allows you to do a little bit more than you used to be able to do in 2.090, but you may be waiting until we add support for files and folders being created in the model upload directory through the Planning Analytics Administration agent before you can actually kind of reproduce all of the steps within this demo. So with that, I'll say thanks and hope you appreciate the demo, the new capabilities that we're releasing within Planning Analytics Workspace. And as always, we look forward to feedback on these capabilities that are being released. Thank you very much.